The third point is that holding period averages are more mathematically appropriate. This is pretty technical, so I won't go too deep, but try to think back to Calculus 101. The concept of integration is typically introduced by doing this problem of Riemann sums. That's where you take the area under the curve and you approximate it by measuring the area of several rectangles underneath that curve. By making those rectangles skinnier and adding more of them, you get a better approximation of the area. Now consider how this might apply to the value creation models. Let's say you hold a company for 4 years. Instead of taking one multiple expansion measurement for the entire holding period, what if we take 4 annual multiple expansion measurements and add them up? Or even better, let's take 16 quarterly multiple expansion measurements and add those up. What you find is that regardless of whether you calculate multiple expansion with the formula in option A, option B, or option C, as those rectangles get skinny, all 3 formulas converge to the option C answer. Option C is always the better fit to the curve. This seems to be a bit strange at first, but it makes sense when you think about these formulas geometrically. Option A is basically the area of a rectangle with delta M on one side and entry EBITDA on the other. Option B is the area of a rectangle with delta M on one side and exit EBITDA on the other. The formula for option C is the area of a trapezoid whose base is delta M and whose sides are E1 and E2. A trapezoid will always fit a curve better than a rectangle. This is why your old calculus text had a section about the trapezoidal rule, and why your old scientific calculator, probably a TI-84, used trapezoids for numerical integration. Option C always provides the best mathematical representation of holding period conditions. So in our models, you'll find holding period averages everywhere, not just for the multiple and the EBITDA, but also for revenue, EBITDA margin, ownership percentages, equity ratios, etc. They provide results that are less volatile, and in general, they make all the equations work better.